You can make money from them?
Okay, so really then, our domain, that's not our domain, right? We can't ever have a negative resistance anyway. So what is our domain? And it can't be all reals either though, because resistance can't be negative. Okay, so 0 to infinity, and we could have a pretty good argument in here about whether we'd include 0 or not. If we included 0, it would be a superconductor, and they exist. So I guess we'll include 0. So there's our domain, right? So that's good because that tells us on our table what values we're going to include on our table. So let's start building our table right now. So what's our this time it's not an x. What's our input variable? Our independent variable? Okay, good, R2. And we're going to restrict that on this domain, so it's all values greater than or equal to 0. Okay, and then our output variable is power, but we need a derivative here, don't we? Yeah. Right? So if we're going to differentiate this, keeping in mind that this is our variable, right? Everything else is constant. Okay, so what do? Differentiate. How do I do that? Tell me, what am I doing here to differentiate? Okay, I could use the product rule. It might be easier if I rewrote this as P equals V R1. I'm going to make the R2s yellow so we can see. What is this? Oh, I'm not going to say it.
Yeah.
Times R1 plus R2 to the negative 2, right? So we can use product rule. Okay, so what do we get then if I calculate P prime? And I could even just leave those out front, right? We could just do this if we want. Just pull those out front and leave it there. We'll redistribute them later, but we don't have to mess with any of the derivatives. So I'm taking the derivative of this product. Okay. And I'm differentiating with respect to R2, right? So what's the derivative? Like if that were an x, what's the derivative of x? 1, okay. So I'm going to get 1 times that factor. Okay. Plus okay, I'm going to put the R2 there. And then I got the derivative of this one, which is going to be negative 2 times hand to the negative 3, right? Times 1. Good? All right, so if we write this, then let's write this with, well, actually, let's go ahead and just factor things. How about? What could I factor out of both terms? Okay, I could take out one, that's a base, common base, isn't it? What power can I undistribute? Negative 3, got to take out the least power, right? Factor out the least power of the common base. So I'm going to get P prime equals VR1 times hand to the negative 3. Well, let's go ahead and just write this as a fraction from the beginning. That just goes on the bottom, doesn't it? Yeah. So we get R1 plus R2 cubed. And on the top then, what are we getting in here? We're getting one of those, right? Yeah. R1 plus R2 minus 2R2. And if we combine like terms, that's just giving me R1 minus R2 in there, isn't it? Yes. Okay, so our final answer for that is P prime equals V R1 times R1 minus R2. Everybody good with that on top? Right, if we just subtract, then we get plus 1 minus 2 of those. And then on the bottom, we've got R1 plus R2 cubed. So there's our derivative. Okay, what do we need to do with the derivative? Critical numbers. Okay? Okay, where do I find critical numbers? Zero or undefined. Is it undefined anywhere? The only place it could be undefined would be where the denominator is 0, right? But that's not in our domain, right? Domain only includes positive values. So it's nowhere undefined, right? So the only critical number we get is where the numerator is 0. Okay, Landon, where's that?
What you just said.
Yeah. So you could just by inspection here, what value is going to make the top 0? The only variable I have is the yellow one.
Well, R, 0, just
Well, what would R2 have to equal?
R1.
R1, everybody see that? Okay, so the only way we're going to get a 0 is if that factor is equal to 0. So my one critical number is going to be at R2 equals R1, right? And if I add my next row, my P prime row, what's the value of the derivative there? 0. So that's telling me then, what about the topology of the graph? Horizontal tangent, right? Good. We know we got a horizontal tangent. So then we want to just know, we're trying to find, what are we trying to find again? We're trying to find maximize power, right? We want to find the maximum power. So we want to see if we can come up with a maximum here. So how can I apply the first derivative test then? Right, what's that first derivative test? If I want to determine if this is a maximum or a minimum, it's a relative extremum, what did I do? Okay, test values, good. Well, so what's a really convenient test value that's in our domain on the left? 0. Why not 0, right? So if I evaluate the function at 0, the derivative function, what am I going to get? I don't care what the value is, what's the sign going to be? Positive, right? Everybody agree? It's going to be positive. So down here we get a positive first derivative. What would be a convenient test point to the right? Well, maybe 2R1 maybe? 2 times R1? We can't pick like I couldn't pick a value like 10. How come? I don't know what R1 is. I don't know if that's bigger or smaller than R1, right? So we could do 2R1. And if I plug in 2R1, what's the sign of the bottom going to be? Positive. What's the sign of the top going to be? Negative. Yeah. Right? Everybody agree? So I get negative over positive is negative. And so then what is going on here? If I go from an increasing function to a decreasing function through a horizontal tangent, what does that look like?
Maximum.
Yeah, it's got to be a maximum, doesn't it? Right? And so we found it. We found that the voltage, or excuse me, the resistance R2 that produces maximum power is when it's equal to R1. So the two resistors have the same resistance. Okay? Make sense? Okay? Sort of, kind of. So this is just a sneak peek at kind of what we're going to do next. You know, the next big thing we do is optimization, where we're trying to maximize and minimize things, right? And so we have the tools to do it right now. We just need more practice with this stuff, okay? All right, so moving on to some couple other little quick questions. So what about this? I'm giving you the picture of a derivative of a function. Sketch a graph of f on the same set of axes. Okay, well, I mean, we've done stuff like this before, right? But now it should be easier for us after we've, you know, kind of having talked about the first derivative test and what it means to be a maximum versus a minimum, right, in terms of increasing and decreasing behavior, the sign of the derivative. Anybody point out to me an important place on the graph of the function, not the derivative. Okay, negative, so this point right, what about this point right here? Now, this is a point on the derivative function, right? But if I'm gonna graph on top of this, if I'm gonna graph the function, what's happening at the function at that point right there, and why? What do you think? Raise your hand. Somebody help me out here. Raise hands. And what do you think, Redmond? What's going on there? The pink graph is the derivative function. So what's happening to the derivative there? I'll give you a hint. Here's a way to think about this. If we're looking at the signs of the derivative, what's the sign of the derivative on this region? The derivative is the derivative function, right?
Yeah.
So it's positive, agree? It's above, the derivative function is above the y-axis, x-axis, sorry. So it's positive there. What is it here?
Negative.
Negative, and here it's negative. So what is a transition from positive to negative? What's that going to look like if we're transitioning from a positive derivative to a negative derivative? Yeah, okay, but what, it's going to be extreme of, what kind? Has to be maximum, doesn't it? Right? Because we're going from increasing to decreasing, so it's got to be a, that makes sense? And what's the shape going to be? Is it going to be smooth or jagged? How come? Because it's not undefined, because the derivative has a value of 0 there, right? So you know that's going to be a horizontal tangent line, right?
Yeah.
Okay, and then over here, this is transitioning from decreasing to increasing, so that has to be a minimum.
Right.
So we don't know, like, we don't really know exactly what the function's going to look like, but if we stitch those together, can anybody want to come up here and draw it, or tell me what to draw? Like, can I just arbitrarily pick a point, like say this is going to be, that's going to be my minimum, because it's increasing to decreasing, right?
Yep.
Okay, that makes sense, right? So there's my minimum, and then this is going to be a maximum, right?
Yep.
So I could do the maximum maybe like right there? Does that make sense?
Sure. But is it undefined?
Well, what's wrong with that?
Don't they have to be continuous?
It does, but then why couldn't the function just, in between, couldn't it just do something like that maybe? Yeah, how come it can't, that can't work, can it? Because if that were the case, Emily, what else would I have to include in there? What else? I mean, what would have, if we did this, so if this minimum were above that maximum, I would have to have another turning point there and another one there. But they don't exist. I guarantee they don't exist, because look at the derivative function. In order for that to work, I'd have to have another horizontal tangent there, right? And another horizontal tangent there, which means that derivative function would have had to have 2 more zeros, which it doesn't have, right? So that's impossible. How do I have to place the minimum and the maximum?
Kind of like the sign.
Yeah, it'd have to be, this one would have to be below this one, wouldn't it? We don't know where though, but it would have to look something like, something like that, right?
Yeah.
Does that make sense? Okay. It's like a puzzle. It's just kind of fun. I mean, it's like a puzzle. You just got to put this stuff together in a way where it's consistent with the information you're given about the derivative. Okay, let's try another one. About this one.
Is this the derivative?
This is giving you the derivative, yes. That's f prime. So what's going on there? Are there any interesting points on the function?
Two. Two,
Any one that's easy to determine, right? Okay, that's an easy one, isn't it? Because we're transitioning from a negative derivative to a positive derivative. derivative. So what does that look like?
Minimum.
Gotta be a minimum, right? So I know that one is gonna be a minimum at 1, okay? What's going on here?
It's horizontal.
Okay, I have a horizontal tangent because the value of the derivative is 0, right? What's the shape though? What's the topology there? It's gonna be horizontal tangent, but I'm going from negative derivative to negative derivative, so decreasing to decreasing.
Is
So
it
what's
gonna be
it?
a?
Ah. So like that maybe, right?
Yeah.
Does that make sense? This is, by the way, what we call an inflection point, but we'll get to that later. Okay, so we know that's what's going on there. So then if I wanted to graph this thing, there's no other turning points, right? There's no other zeros of the derivative. Agreed? So then I know that, that this one has to be higher, doesn't it? Because those have to knit together. So it'd have to look something like, we don't know exactly where. We don't know. Oh, yeah. Something like, yeah, you get the idea, something like that, right?
Yeah.
Okay? How about that one? Now I want you to estimate the intervals on which the function is increasing and decreasing, and also estimate the x-coordinates of all local extreme values. So one more thing on this. That's one possible graph, but isn't this an equally possible graph if I just did something like this? Right? How do I know which one it is? I don't. I'd need some additional information, which I don't have. Right? All this is giving me here is the x values, the x values corresponding to the point of inflection and the minimum. But I don't know anything about the y values. There's no information given to me about that. Right?
Yeah.
Okay? How about this one? Where's the function? On what intervals, can anybody tell me, is the function increasing? Raise hands.
Is that -1, or is it negative infinity?
Okay, so negative infinity to 0. Okay, good, because we see that here's a 0 of the derivative, so everything to the left of that is where it's going to be positive, right? The derivative is positive value. So it's going to be increasing every place over there, isn't it? So increasing on negative infinity. Now, what, do I include 0?
No.
I don't, because it's not increasing at 0, right? At 0, the value of the function is 0, okay? Where else?
2.
Ah, okay, 2 to 3. It's also increasing on this interval in there, right? And then decreasing on the other ones, right? Okay. Where's the x-coordinate of a relative maximum?
0, 0.
Okay. So I don't know what the y-coordinate is. The x-coordinate is at 0, right? Because I'm going from increasing to decreasing. And so at 0, I'm going to have something like that. Okay. Where else? At 3. I'm going from positive to negative, so I'm also getting one there. And I'm going to get a minimum there, right? Okay? Because I'm going from negative to positive, first derivative. And so if I wanted to knit those together, if this one would have to be higher, that would be lower, that would be higher, right? So something like, that, right?
Yeah.
Okay? With that one. So I'm given a graph of the first derivative here of f prime. So what are the locations of relative extrema?
Maximum 1.
Yeah.
-7.
-7 is, okay, good, because I'm going from, this is f prime, right? So I'm going from positive first derivative, so that's increasing, to negative, decreasing, -3, we're going from increasing decreasing, and
So
-1. Right there. We go to increasing. What's going on there? What's going on at that spot? Does the derivative exist there? Oh, it's defined.
This is a P spot.
No, this is the, that's a bad prime, but this is the derivative function, right? So it's defined. There's no hole in that function.
Is it a P spot?
It's not continuous.
It is continuous. I can draw the derivative without picking my pencil off the board, right? So what's happening there? It's not as mysterious as it looks. The derivative is just, the value is decreasing, it's decreasing, it's decreasing down to some minimum value of the derivative. So it's the most negative there. It's a steep negative. And then what happens? Well, it just starts to become more positive from there, right? So what would that, if I were going to graph that part right there, what would it look like? If this is -2, then the function is just, it's at its maximum negative steepness there, right? Because the value of the derivative is slope. So there's going to be some place right there where it's really steep and negative,
And is it just,
and it's going to be doing something like that, and on this side it's going to be doing something like that. That's it.
it's just like a sideways?
Yeah. Kind of, yeah. Make sense? Okay. Are any of, okay, well, I guess that's good for today. Are we out here in a minute?
Yeah.
Okay.